Many developers think that great software is all about the perfect design up front. But here's the truth. The best systems aren't finished. They're built to grow. Extensibility isn't just about adding features. It's about building systems that evolve gracefully, no matter what the future holds. In this video, I'll show you how to design for growth without sacrificing stability. So let's dive in. Hello world, I'm David Scott Bernstein and welcome to The Passionate Programmer, where we unlock the principles of building smarter, more adaptable software. In this video series, we're exploring the virtues that form the foundation of great software. This video is focused on extensibility, the ability to grow and adapt systems without breaking what already works. By the end of this video, you'll understand why extensibility is essential for building systems, and you'll gain practical tools for applying this virtue in your code. First, what is extensibility? Extensibility is about designing for flexibility. It's the ability to grow your systems without disturbing its foundation. Think of it as preparing software to evolve effortlessly. Extensibility is the capacity to add behaviors or features to a system without modifying its existing structure. Consider a smartphone. The operating system stays stable while new functionality is added with every app you install. That's extensibility in action. This prepares systems for change, whether it's a new feature or an integration. It ensures smooth compatibility with third-party tools and services. Imagine designing a city. If you leave space for new roads and buildings, then the city can expand seamlessly. But without foresight, every addition disrupts traffic and raises costs. Extensibility ensures your software can grow sustainably. Without it, even small changes can lead to major rewrites, wasting time, money, and morale. Extensible systems handle new requirements without breaking existing functionality. Years ago, I worked on a payment processing platform. It only handled credit cards initially. When the business wanted to add crypto payments, we had to basically rewrite the core system because it wasn't designed for extensibility. What should have taken days stretched on for weeks. Extensible designs reduce costs of adding features over time, much like modular homes simplify expansion. By reducing dependency tangles, extensibility frees developers to focus on innovation instead of firefighting. Extensibility doesn't just support change, it fosters emergence. Emergence is when basic elements combine to produce complex behavior. For instance, think of birds flying in synchronization, not because of a leader, but because of their interactions as a flock. A web browser starts simple, but with extensions, it transforms into a streaming platform, a gaming hub, and a coding environment. Nature is the perfect model for extensibility. Evolution always builds on what exists, like wings evolving from limbs. Similarly, software grows best when it extends and not replaces its foundation. Now let's explore some practical ways to make your code more extensible. Here's how you can design for flexibility. Use design patterns. Design patterns are built with flexibility in mind. For example, the strategy pattern enables behavioral swapping. By swapping strategies at runtime, we maintain flexibility and scalability. Think of browser plugins like Grammarly, which extends functionality without touching the core code. Inheritance and polymorphism allow extensions, like a shape class with circle and rectangles as subclasses. WordPress thrives on extensibility through plugins and themes, transforming a basic CMS into a dynamic platform. Let's look at a demo real quick. One of the most powerful features of object-oriented programming is a technique called polymorphism. It provides extensibility, and it's really the main benefit of using OO, or at least one of them. Here's a class diagram. In this diagram, we have a document, and the document contains a sort strategy. It has one of these kinds of sorts that it can hold, a shell sort, a quick sort, or a merge sort. And it's held through an abstraction, which you can see right above, called sort. We know it's an abstraction because the UML calls that out by making the name italicized. What the client does is they new up one of these sorts, shell sort, quick sort, or merge sort, and put it in an upcast of sort, and then passes it on to document, and document uses it. But the problem with this design is that the client becomes aware of what the derived sort class is, because it has to in order to new up that sort class. And we want to hide the type. This is a key aspect of type encapsulation, so that we can add new types in the future without affecting client. So instead of having the client do the new, we delegate to another entity. We call it a factory because it's responsible for creating objects. And the factory instantiates one of these sorts and passes it back to client, and client doesn't know which one it has. It just knows to pass it on to document. And document doesn't know which one it has either. It just knows it can call the sort method on it. And it does, and the work is accomplished. So what's the advantage? The main advantage is that we've allowed extensibility to happen with minimal rework. So let's say we want to add a new sort. We decide that there's a new kind of sort that we want to add. We can do that in a way that doesn't affect the client or the document. We simply add the new sort as a subclass. In this case, it's called bubble sort. We update the factory for the new rules to when bubble sort should be instantiated and used. And that's it. There's no third step. Client and document remain unchanged, but they can take advantage of the new bubble sort. And that's really powerful. It means that we can build extension points in our code throughout. And that gives us an enormous amount of flexibility. This is one of the main reasons why we're using object-oriented programming. Let's look at the code. This is Java code. If you're not familiar with Java, you'll get the gist of what I'm saying. On the first line, we're declaring an abstract class called sort. And we introduce an abstract method called sort, which takes a document as a parameter. Notice there's no body to that method. It just is a call. It just is a method signature. Because it's abstract, we'll override it in subclasses and provide a body. And in fact, that's exactly what we're doing below. So you can see we declare classes shell sort, quick sort, and merge sort. They all extend sort, which means they're subclasses of sort. And they all introduce their own sort method to do sorting their own way. Conceptually, it's sorting a document. The end result will be the same, but the way they do it is different. Here, just shown in comments, but that's where I would actually put the implementation. Now, how do I put this all together? Well, somewhere else in my code, I would have a document class, and maybe I have a prepare document method. And in that method, the first thing I'll do is I will get an instance of the sort that I want to use from my sort factory. And you see it returns a sort strategy from the factory. And notice the factory isn't very smart. It just always returns a new quick sort. But that's where I could put the rules, if I wanted to, on which sort to return. Once I got the sort back in prepare document, then all I have to do is call the sort method on it. Boom, and I'm done. It sorted the document. So that's the idea. And this is how we get extensibility in an object-oriented programming, or at least one of the ways. Use abstractions or interfaces to decouple dependencies. Follow principles like the solid principles. Extensibility isn't just about today's code. It's about the foundation of future-proofing systems that thrive in a rapidly changing world. Extensibility prepares systems for rapid change. It ensures adaptability for future demands, from AI integration to quantum computing. If this video sparked new ideas, then hit the like and subscribe button. Let's build systems together that are resilient, adaptable, and future-ready. In our next video, we'll explore a virtue that ensures your software is trustworthy from day one: testability. You won't want to miss it. If that video isn't up yet, then subscribe and hit the bell icon to be notified when it comes out. Join me on this transformative journey. Let's code smarter, live better, and create software that truly lasts. Happy coding.